Suzy is a high school senior who wants to get into a big-time college in New England. She is studying hard so she can be a science teacher someday for students like herself before starting her family. Here she is using a candy thermometer in her kitchen because candy needs to be heated to a precise temperature in order to caramelize the sugar properly without burning it. Let's ask her a few questions. Hello, Suzy.
Well, hello, Professor.
How's the weather, Suzy?
Gee, it looks swell out there. Nice and sunny.
No, Suzy. I meant more specifically, more scientifically.
Well, the thermometer outside reads about 58.
And inside?
I have the thermostat set to about 70.
Suzy, are you feeling well today?
I feel swell.
Well, what if you were not feeling well? What then?
I suppose it would be important to check my temperature.
That's right, Suzy.
98.6, all right.
Good to see you're well, Suzy. Isn't it great that to measure the precise temperature of the weather, our bodies, and our food, we have such a precise tool to help us?
Yes, I guess we can thank Galileo for that.
I can see you know your history, Suzy. But how about the science itself? Can you tell me how those great thermometers work?
Well, the red stuff changes location along the printed chart here.
Yes, Suzy. But how does that happen exactly?
I'm afraid I've never thought about it.
That's all right, Suzy. Let's get started. The folks out there can follow along. The thermometer contains some type of fluid, generally mercury. Bulb thermometers rely on the simple principle that a liquid changes its volume relative to its temperature. Liquids take up less space when they are cold, and more space when they are warm. Suzy probably works with liquids every day, but she may not notice that things like water, milk, and cooking oil all take up more or less space as their temperatures change. In these cases, the change in volume is fairly small. All bulb thermometers use a fairly large bulb and a narrow tube to accentuate the change in volume. You can see this for yourself by making your own bulb thermometer from scratch. Here's what you'll need. Number 1. A glass jar or bottle with a watertight lid. The lid should be a screw-on kind and made from metal or plastic. The jar needs to be glass so that its shape does not change when you squeeze it. Number 2. A hammer and a large nail. Number 3. Some putty, caulk, or chewing gum. Number 4. A drinking straw. Number 5. Some food coloring to make the results easier to read. Now, punch a hole in the lid of your jar. The hole should be as close to the diameter of the straw as you can get. Then insert the end of the straw into the hole, and then seal the hole with your putty, both on the inside and the outside of the lid. When you are done, it should look something like this. Now fill your jar with cold water. You can do this either by filling it with water and leaving it in the refrigerator overnight, or by making some ice water in a pitcher, and then pouring the ice water into your jar, straining the ice out in the process. Add the food coloring. Put the jar on the table to keep it steady. You want the jar filled to the brim with cold water, as full as you can get it without overflowing. When you screw on the cap, a little water may spill out the sides, and a little water may be visible in the straw. That's okay. Place the jar in your kitchen sink. Plug the sink, and run hot water into the sink until the sink is about half full. Now, watch the level of the liquid in the straw, and a very unusual thing will happen. You will see the water in the jar expanding right before your eyes. As the water in the jar gets warmer, it will expand and rise up the straw. This sort of expansion happens every day, but we don't really notice it because the amount of expansion is fairly small. Here, because we have routed the expanding water into a narrow straw, it is much more obvious. We can actually see it happening.
So my fudge is 235 degrees. It's almost done.
Excellent, Suzy. Now, when will that be cool enough for me to try a sample?